Kenwood KR-8050, and this is kind of a unique little receiver. It's not really talked about a whole lot. I think it's kind of a sleeper if you ask me, but it's kind of cool in some ways. It's a high-speed direct coupled amp, and this is kind of that Kenwood high-speed DC series, and it only has 4 output transistors, 2 on each channel, but it's rated at 120 watts per channel, which is pretty good. And it's got this orange power turbo boost button that if you push this in and you have an 8 ohm speaker load, it'll let you turn the amp up to 11 and you'll get 150 watts a channel instead of 120. It's another one of those gimmicks, you know. But bottom line is it's a fairly decent amp, and a couple things I really like about it. So the output transistors, they're TO3 case transistors. This is a TO3 case for those of you who don't remember. And they're kind of a late version of them because they have the transistors that are in there are high frequency. They're 20 megahertz transition frequency, where a lot of the ones are, you know, in that 4 to 6 megahertz range. So these are actually high-speed transistors. This is kind of getting into that era in the late 70s, early 80s, where people were getting into that TIM distortion thing and all that, and they wanted these ultra-high frequency transistors and everything. So this has that. It has a really cool tuner in it. It actually has a pulse count detector. And if you watched my previous video that I did a little while ago on the Pioneer F26, I kind of showed you a little bit about how a pulse count detector works. It's different than a ratio detector or a quadrature detector. So it's a really good tuner in this, believe it or not, for what it is. It has every feature you could want on it. It has a 50 hertz boost. It has bass, mid-range, and treble controls. It has a high filter. You can actually do direct input coupling or capacitor input coupling, depending on which way you move that switch. You have a loudness switch. You have 2 different sensitivity levels for the tuner. So you can have, you know, high sensitivity and low sensitivity. You actually have wide and narrow bandwidth. So these are all things that usually show up in higher end tuners. And I don't know if any of you know this or not, but Kenwood is known to be one of the best manufacturers of tuners of this era. So they actually have the experience to make an amazing tuner, but usually in this generation of stuff, you didn't see that. But this one kind of seems to be an exception. Has 2 phono inputs, has reverse stereo. I mean, it's pretty laid out. And most importantly, it has a microphone mixing. So many stereos have a microphone input, so you can sing along, I guess, like Mr. Microphone.
Hey, good looking, we'll be back to pick you up later.
I don't know. But down in the comments, any of you, have you ever used a microphone input on your stereo? Like now I'm not talking a PA system, I'm talking your home stereo on your home system. Have you ever used that microphone? I never have. I just haven't. I mean, I had stereos with microphone inputs. I've never used it. But let me know in the comments if any of you ever have and why. Did you use it to record something? Or did you use it like almost like karaoke back in the day? I'm curious. Let me know. All right, so first things first. When I got this thing, and again, this is one that Dave found, it has this wired into the power cord, and it seems like it's plagued with another one of those Kenwood power switch issues. Kenwood is notorious, and they have power switches that are in the speaker knob, power switches that are standalone, like this one. Doesn't seem to matter. They just seem to have problems with power switches. The Model 11 and so forth, those ones, they had that timer on the power switch, and those power switches go bad all the time. So anyway, I don't know why, but they do. So the first thing we're going to do is try to repair this power switch and then put a brand new, little bit heavier, as you can see, heavier wire power cord in there. And kind of get this back to factory. So let's do that first and see where we are. Anytime I get these on the bench, I don't just plug them in without taking the covers off, because you got to remember, these things go through shipping, they get carried in cars, all kinds of things before they make it here to my shop, and then they lay here around for a long time. I don't know if something is rattling around in there, or came loose or shorting, so I just always take the cover off and look at it first before I power them up. So let's get the cover off. Okay, just looking inside, everything looks to be pretty clean in here, all around. Everything looks really good. Maybe just a little bit of normal dust, but actually this thing's been kept somewhere in really nice condition. So I don't think this is going to need too much of anything. Let's check for DC on the outputs. I mean, I don't have full power to this thing, but it should be pretty clean. So let's look. Can you see the meter? I can see the meter. Let me rotate this so I can turn speaker A on. So we're on speaker A. Okay, left channel. I have 16 millivolts. That's doable. How about channel 2, or channel B? 34 millivolts. So yeah, there's no DC. Of course, there should be nothing on these because they're disconnected, and there's not. Okay. That looks really good. So far, so good. Okay, I have some speakers and an antenna connected. Let me turn this on, and I'm going to add a light bulb to it. And that should give us current limiting a little bit, but it's not going to get in the way of testing the amplifier. And make sure I have my speakers, and I do. So let's go to FM and see if we can tune anything in.
A CDC update.
Wow. Okay.
Pneumococcal vaccination.
Okay, so we got some issues. All right, so when you hear that abrupt sound, like where it cuts in and out as you're turning that, that means that the rotor on the tuning gang is probably dirty or corroded, and I can see where it is a little bit dirty. So it's going to need, it's got some of that green stuff on it. So those are going to need to be cleaned. That's very simple. Just put a little bit of deoxit in there and work it back and forth. It'll be like new. So, and it's not going to tune properly until you get that. Now the detector on these, since it's a pulse count detector, there's really not a lot of alignment to do on those. They're all kind of, I won't call it digital, but it doesn't require alignment because it's like logic controlled, let's put it that way. So it should work really well. So I have sound out of both speakers. It sounds good. So let's just clean that rotor and see if that'll straighten that out. Okay, I'm going to just start out with some of this, this QD doesn't leave any kind of residue. Because when this is on the plates like this, it will throw off the tuning, so you have to wait for it to evaporate. So right now I just want to clean it, so I'm just going to run this back and forth. Just like that. You can see that green stuff in there. I just want to wash that out of there. And I'm not even going to worry if it gets down here, because it'll dry up and evaporate. I'll mop a little bit of it up with a paper towel, and then the rest of it will just evaporate. And then once we're done, we'll take a little bit of this deoxit D100, and I'll just put a tiny drop on each of the rotor bearings there. And that'll be it. it should work after that. Okay. Okay, so got that all cleaned off. Now what I'm going to do around the camera here is I'm going to just put a little drop, turn on a little bit of light here, one little drop in each bearing. One there, one there. I'm just going to go right across here and get them all coated. Just a drop's all it takes. And one last one here. And again, that spray still has to finish flashing off of there so it doesn't turn on. See if it comes out of protect. Yep, there it goes. See that? Now it's perfect. All right, can't leave any of that on very long, but it's even in stereo. You can see there the stereo light is on, and we go to wideband, or that's narrowband, there's wideband. So that's all it took, and that got rid of that cutting in and out. So it's just as simple as that. Now one thing I will say is this is really stiff moving up and down. So what I think I'm going to do is I'm going to remove this switch. It's only 2 wires. Now, I probably have to get the faceplate off to do that. And I'm going to throw it in the ultrasonic cleaner and clean it, and then relubricate it, and then put it back in, and it should be good. Okay, remove the knobs. 2 nuts here, one on this side, one here, and then 2 screws up here, and then it comes right off. Nice. Easy. That's the way I like it. Okay. Okay, after a dip in the ultrasonic cleaner, it looks like brand new, and it measures perfectly, and it works very easily now. So it just needed to be cleaned. And I went ahead and wired in the new power cord. Just took the old one out of the strain relief and put this new one in. And I did have to use a little bit bigger strain relief, but just barely. So I just had to file it out a wee little bit. Fit right in. So let's get this connected, and we can put it all back together. Okay, new switch is installed, and let's put the faceplate back on. While I was at it, I just gave the controls a quick spray, but they were actually good. None of them had any noise or anything on them, so that was good. Okay, you'll have to excuse the ultrasonic cleaner. I'm cleaning all the control knobs off of here. But as you can see, all of these are working. I've replaced 2 bad ones already. And here's this last one that's bad. And I was just going to show you what I do. If you bend these pins out, they're just kind of folded over there. You can just pull this out, the old bulb. And luckily, I found some really crusty old, brand new stock, new old stock, whatever you want to call them. They look almost like Christmas miniature bulbs, but they're not. They're the little bayonet style. And if you bend these up with a pair of pliers, like so, you can pull this little base off of it. It'll just come right out, kind of like this. I can do it without breaking the bulb. Like fingers don't want to grab it. Oh, there it goes. That was a noisy thing. I'm glad that's shut off. Okay, and that just pulls out like that. And then I have a similar looking bulb. Now these ones are a little bit higher voltage rating, which means they're not quite as bright, but you almost can't tell. And then you just put this in here. And so they should last a really long time. And then you just kind of bend these over like this and feed them through the outer holes. Kind of like so. I mean, I could probably try to order the original grain of wheat bulbs that went in here, but I don't really want to wait for them. So I'm going to get this thing out so Dave can take it with him. This one's been sitting here for a year or more. I just haven't had time to get around to it. So, and then you just pull it up through on that end. Grab this one and pull it through till it's, you see how those are in there like that. I don't know if this thing will focus. And then it just pushes right over those two little pins down there, and I'll show you in a minute how that goes. Just little silicone things. These are nice to replace. So you can see the two little pins that stick up in there. I think you can just make it out. And when I put this on here, it just slides down over those two pins and makes contact. And now we have all the lights. Now I haven't checked these two here. I know the stereo one works, and I don't remember what that other one is. Let's take a look at it. Oh, the protect. So yeah, that works as well. And power boost is not working, so I will need to replace this one here as well, which is the power boost. So I'll shut that off. I'll grab that one out, and I'll do the same thing to this one. Just kind of pulls off, and we'll replace that. Okay, let's see if we get power boost. And we do. All right. You might ask why I didn't put LEDs on there, and the main reason is I don't want to have to mess around with dropping resistors and rectifiers and everything, because this is AC for these little bulbs, and I don't really want to have to convert all that. And these bulbs will last a really long time. Okay, let's see how we did. That is nice. And no scrubbing. And it even got in between all the little ridges there. That's what I like. Those look like brand new. Perfect. So all I did was I filled this up with, I put a little bit of like just cleaner, just general cleaner degreaser, and then filled it up with water. And then I just set this in the solution inside the ultrasonic cleaner so it doesn't get in all of that mucky stuff and it doesn't fall through the basket, because these little covers are small. And that makes it really easy, and it turned out perfect. Look at that. Nice. Okay, let me get these on. Okay, we're all assembled and it looks really nice. I'm really happy with it. And I have test equipment connected. Let's see how close I can get in here and see everything. Okay, we'll do our basic 1 kilohertz test, and I'm going to do with the power boost button out and with the power boost button in, and see if, and we are on an 8 ohm dummy load, so apparently this thing should go into clipping at about 120 watts per channel with the power boost button out, and then with power boost in, it should go up to 150 watts per channel. And again, we'll look at the rest of this here in a minute, but I just want to see how that works, and then we'll give it its basic test, and then the last part of the video, we'll look at the schematic a little bit, how some of these things work, because they're a little bit unique. This power boost must be something similar, I'm going to guess, to what that Techniques amplifier had, or receiver had, where it had a power boost also based on speaker load, but it was automatic. It had a relay that would sense when you had a 8 ohm load, and then a relay would switch instead of you manually pushing a button in. So I have a feeling this is going to be a similar thing, but it's just manually actuated, which I think is a much better idea if you're going to do something like that. Anyway, let's go. So, clean looking signal. I don't have the distortion meter on yet, but let's bring this up to, so right about there is clipping. You can see the bottom part is clipping, and we're at about 32 volts RMS. So 32 squared divided by 8 is 128 watts per channel. So it's making its 120 watts. So now what I'm going to do is I'm going to push this power button, the power boost. Look at that. And then I'm going to connect this back up. All right, let's go now and see what we get. So we'll take it up to just to clipping and back it off again, right about there. And you can see we're just a little bit, let's call it 36, let's just call it 36.5. All right, so 36.5 squared divided by 8 is 166 watts. And it's supposed to be 150, so it's making its numbers. So let's hook up the distortion meter and see what our distortion looks like. Okay, here we go. So power boost is out right now. We'll bring it up. All right, there's clipping. We'll take it down below. Wow, look at that. Fantastic. Okay, let's turn on power boost. I doubt that this is going to change anything. Take it up to clipping again. Right there. Back it off. Right around that 150 watts per. Not bad. Very good. Okay, so now what I'm going to do is I'm going to turn the tone controls on. They're all flat. And let's go to a square wave. And of course, I'm not going to drive this super hard. We're going to go way down here. I just want to see how the tone controls work. Okay, let's get a square wave. And that already looks pretty funky, doesn't it? So, why? That's not good. That tells me we need to clean some controls, huh? All right, so I didn't get these clean enough. I'm going to have to clean them. Maybe, yeah, I may even have to pull the board to do that. So, good thing we checked. That's why you always check these things. So, I guess taking it back apart. Okay, into the ultrasonic cleaner we go, and then there's no, I don't see any capacitors here that will give us any trouble. Very good. Those, what the heck are they called now? I'm having a senior moment. They're those clear capacitors with you could see the aluminum foil inside. They're not polyethylene, I forget what they're called, but those types of capacitors that have the real thin aluminum foil in the plastic, clear plastic casing, you do not want to put those in an ultrasonic cleaner. Bad idea. The rest of this will be just fine, it'll survive. These orange caps, they all tested the same with the ESR meter, so they're either all kind of worn down or they're all still good, I don't know, but I'll probably end up recapping this since I have it out, and these are the critical audio path capacitors for the tone controls. So let's do that after we get this cleaned. Okay, so I just have one of these orange, I don't know if you could see them, these orange capacitors. And the failure mode of these things, these are audio grade low leakage capacitors. They don't always develop high ESR. They actually keep a low ESR, but, and I'm sure you're out of focus here, but what they do develop is leakage. It's kind of ironic. They're a low leakage capacitor, and their failure mode is they get leaky, more leaky than than other electrolytics. But as I said before, these ones were good. And here's one that's up on the leakage meter, and I'm on the most sensitive scale, which is the 50 microamp scale, and I have less than 1 microamp of leakage on there. So as you, I mean, it's literally just a fraction of a microamp. So these caps aren't, and I tested several of them, and they're all good. So I think they're, you know, they don't need to be replaced, but since I have it out, I'll swap them out anyway. And just for reference, here's a Nichicon Gold series. It's been sitting in a bin for a long time, so it has to reform a little bit. But you can see it has exactly the same amount of leakage. It's literally a fraction of 1 microamp. Now, in addition, when you put this back, before you put this back together, it's a good idea to drizzle just a tiny little bit of some kind of control conditioner, you know, like deoxit green. Let me see if I got the kind that I put in there, which is this stuff. You just put a little tiny drop like down in the middle of it and kind of let it soak in. Just a drop, not even a drop, tiniest little bit on, just the little drop on the tip of the needle there. Drop it in there and then work it in. That'll just kind of keep the thing from, you know, metal on metal, especially with the shaft going around, you know, because a lot of that oil and so forth that was in there has been washed out by the ultrasonic cleaner. You want to put that back in. So that takes care of all that. And same thing with the switches. You want to just put a little tiny bit of red deoxit in there. So that takes care of that. And we're ready to look at some schematics. I'll show you real quick how to do the bias on this. This is nothing really special, but I'll show you real quick while I got it apart. By the way, these lights, I did change these for LEDs. They do flicker on the camera. I'm seeing that. But when I look at them in real life, I can barely see anything at all. But if you look at it in the camera, the shutter roll actually picks it up and it looks like it's flickering. So that is not a real life thing. That is just a camera thing, just so you know. Okay, so the first thing I did is I just disconnected the speaker wires from the dummy load and just plugged them straight into my meter, and I'm on DC millivolts. And really you want it to be near 0 millivolts, you know, 0 volts DC. And you can see it's just bouncing around that 2 millivolts, and that's fine. You're being a one-turn pot, if you start messing around with that, you'll just fiddle around and you'll end up settling right there again. See, what it does is the transistors heat up and cool down, and kind of that's your bias circuit taking care of of any kind of drift from the transistors. So that one's good. So let me plug this back onto the dummy load, and let me unplug the other ones. And again, that looks pretty good too. Again, these are single turn pots. You don't want to, I really don't want to touch them because I know what happens when you move those. If I was doing a complete restoration on this, I would put a 10-turn pot in there. I don't even know what value that pot's supposed to be. I could probably look on a schematic, but if it's good, I'm not touching it. Okay, looking down inside here, if you look on the back of the transistor socket, these are socketed transistors. There's a ribbon cable with a red wire, I forget what else. It's a red stripe, an orange stripe, and I think a yellow or brown, something like that. And basically the pin that has the red striped wire, so you see how these are? See how there's like different colors? The one with the red stripe down in here, you want to connect on that one for this transistor, and then the red striped wire on this. And essentially all you're doing is you're going from the emitter of one transistor to the emitter of the other transistor. So that's what that is. And you want to see about 17 millivolts, 17 and point, well, they're saying 17.6 in the manual, but I have the page printed out here. So essentially, you're going to connect between the emitters. You're going to adjust these outside pots. These inside ones would be for the DC offset if we had to mess with those. And you're just going to turn it for 17 millivolts. See, that one's a little bit hot. And I'll probably turn this pot and it'll probably go nuts. So I'm going to go very carefully. We may have to put a little bit of deoxit on this pot, but we'll see if we can adjust it. That's the wrong way, right? Is this pot all the way up? It is. Somebody had this thing turned all the way to max. So we're going to move it to 17. 17.6. That's what they want, right? Okay. And this has been on for a while, and it's not warm, but it's above room temperature. Okay. So now we'll go to these red wires. So hook on this one here, and then hook on this one up here. And you're going to need some long hook leads to get down in there, because it's kind of down there a little bit. That's why I have those longer ones. You can see. And then, let me see if I can get up here to where you can see everything in shot. There we go. And that one's a little bit low, so we'll turn that one up a tiny little bit and try to bring it up to 17. Wrong way. And that's all we get out of that one. That one's maxed out. That turns it down. That turns it up. So 10 is all you can get out of that. So it tells me that one of the transistors might be a little bit weak or something, but that should be close enough that you won't get any kind of crossover distortion or anything. We'll try it and see. I really don't want to go troubleshooting components and things on this when I don't think anything's really that bad. So let's look at the schematic now. But that's it. You just adjust those two settings. So unfortunately, this is one of those annoying service manuals where they print the schematic on 2 pages and they're kind of spliced. So really, if I wanted this to overlap, I'd have to cut it and then kind of piece it together kind of like that. But really, the main part, at the input, there's nothing special about it really. You have your phono stage, you have your input circuitry, tone control, all that stuff. And then it goes into your power amp. And oh, there is a setting also for the power meters, which I didn't check. There's 2 pots on the amplifier board back here. Right here on the protect and power supply board and everything. These 2 pots, you basically put 3 watts into a dummy load, and you measure it with an AC voltmeter across an 8 ohm load till you get exactly 3 watts. And then you just set these 2 potentiometers till the needles on the meters say 3 watts. Very simple. So that's all you do. Okay, looking at this schematic once again. We'll just go over the interesting things, because again, the front end of this is pretty much you have your tuner circuit and everything, and you have your standard tuning gang, capacitor gang in here with your RF. But this again is one of those pulse count detectors. So there's really nothing, and I explained this, I'm not going to go over this all over again. I showed you an actual graph and kind of a chart of how a pulse count detector works. Go back and look at my Pioneer F26 FM tuner video, and I talk about pulse count detectors. The good thing about them is it's all done with logic circuitry. It's logic controlled. So really, you don't really have, you're not doing like a discriminator alignment or a ratio detector alignment. There's none of that. It's pretty simple. And then you do have the intermediate frequency, but again, this is a little bit later design of a tuner, so you don't have a lot of those adjustments on there. And in fact, if you look up at the tuner board, there are a few transformers on here, but not very many. There's a couple of pots for your multiplex and a couple things like that. But by and large, you know, and your muting and a few things like that, but by and large, these should never go out. I mean, unless something goes wrong with the tuner, you should never have to mess with that. It probably won't go out. So again, that's your tuner. You have a phono stage, and it goes into all your switching and selectors and all that. And then it comes into this circuit, which is your actual power amp. And the power amp on this is a little bit unique. It works a little, in some ways it works kind of like that Techniques, what was it that I did a couple months ago. Go back on my videos. It was the, I can't even remember what it is, something or other 800, RS 800 or something like that. But it had that power boost thing, but it used a circuit that would sample the speaker load when you turned the amp on, and then if it saw an 8 ohm or bigger load, it would switch in a bigger, you know, a higher voltage taps on the transformer. And that's what this is doing, except you just use that push button and you manually switch it in and out of power boost mode instead of having an automatic switching. And the thing that, and you can see right here, there's two sets of windings. So you have your center tap that goes to ground, and then you have a pair of windings that are 40, what's it say there, 44 volts. Yeah, let me look, stick my head in front of the camera. Yeah, so if you're using these two inside windings, you're putting 40 plus, you're putting a 44 volts, 44 volts AC into the power supply. If you push that switch, see that switch right here? You're disconnecting these two windings and you're connecting the two outer windings, which are 50 volts. So you're putting an extra 6 volts on each rail of AC voltage. So when you rectify that, it's going to add a little bit more than 8 volts DC. So it's going to raise your DC rail to about 8 volts higher than it would be at the 44 volt rails. So that's where you get your 150 watts instead of 120 watts. That's it. Why they do that, I'm not sure. It's probably because if they would have just put a little bit larger power transformer and maybe a little bit stiffer capacitors. I mean, right now you have two 10,000 microfarad capacitors for your power rails. If you would have raised them like they do on the Pioneers, you put a 20,000 microfarad caps in there, put a little heftier transformer in there, you wouldn't need that switch. It wouldn't matter. But really what's going to happen is the power supply is going to go soft on you when you drive a heavy load. If you have those outer windings, those plus and those 50 volt windings instead of the 44 volts, and it'll drive it into clipping a lot more easily. So they just limit the power to the 44 volt. So it's kind of a way to squeeze out a little more power to the amplifier without having the cost of a bigger transformer and bigger power capacitors, because really those are some of the biggest expenses in the whole amplifier is the transformer and main filter capacitors. So anyway, it is what it is. Kind of neat. The other thing that kind of surprises me is for a 150 watt per channel amplifier, they're only using 2 transistors on each channel. So here's the left channel, here's the right channel. And you can see you only have one NPN and one PNP for the outputs. You know, lo and behold, that's exactly what it is. So those are 200 watt transistors. And they're kind of special because these things have a transition frequency of 20 megahertz. So they're high frequency transistors, kind of like what you saw in the some of the Kenwood got into this in their later models, as did Sansui as well, and Pioneer. You know, Pioneer was using those ring emitter transistors, like on the SA what was it? SA9500, SA9800 amplifiers. And then if you got into like some of the S20 series, you know, their high-end amps, some of those, like I think the M22 or the M20, those ones had ring emitter transistors. The Sansui AUX1, for instance, used them for their outputs. And the whole idea was that by having a faster output transistor and faster transistors, these were all high frequency transistors in here, that would make the feedback circuit react more quickly, and that supposedly would reduce distortion, especially a type of distortion that was known back then as transient intermodulation distortion, or TIM distortion. That's a pretty controversial subject. I guess you could say that it is something that exists in some form, but it doesn't really matter. And if it does exist, you really can't hear it, although there are people who claim they can, which maybe you can. When it comes to audio, for those who hear something, no explanation is needed. For those who can't hear it, no explanation will be sufficient. I mean, that is kind of like the rule of audiophiles, you know. So never argue with an audiophile when it comes to how something sounds. That's my point. So the only reason I'm saying all this is that's a lot of power you're asking to deliver through these two transistors, but obviously they do it. And if you do need to replace these and they go bad, you're going to find that a TO3 cased transistor that has a 20 megahertz transition frequency, you're not going to find those right now. I mean, they're really hard to find. There are some still around that are in the TO3P, you know, the square cases, and you might have to modify the socket a little bit to get that to work. But you can probably put those MJ 15004, 15005s or something like that. The big, the MJ series transistors, those are 250 watt each instead of 200. They have a higher current rating, but they have a transition frequency of 4 megahertz. Some of them are 4, some of them are 6. None of them are 20 megahertz. Will that make the amp sound different? I don't think it would, but there are folks who say it would. Since it has a lower transition frequency, obviously you'll have less problems with oscillation, although I've never heard of these amps oscillating or having problems like that. Kind of like the AUX1 would oscillate if you looked at it crooked. These do not. And part of the reason that these are stable is you're not using paralleled transistors and emitter resistors and all that stuff to try to equalize. You just have one NPN and one PNP, and that's it. Nice and simple. You don't have to worry about anything, mismatched or anything like that. Transistors, it just works. So those are a couple interesting things that they did in here. It also has a JFET input pair, as opposed to a bipolar transistor input pair. And then it has an actual transistors for the current mirror. So yeah, it's pretty cool how that all works. I like the high impedance inputs and so forth. So it's a pretty solid design. There's nothing real special other than that. It has your basic, bias circuit to adjust your bias. I think there's I can't tell, it's so tiny, it's hard for me to see across here, but it's pretty much a garden variety amplifier design. other than this power switching and these high frequency transistors and the fact that they're only using 2. Normally you'd see 4 of them, you know, 2 paralleled NPNs and 2 paralleled PNPs. But that's it. So let's put this thing together. It's all fixed and ready to go, and we'll play a tune on it and call it a wrap. All right, all put together. I have some music queued up. This is going to be some kind of bass heavy music because I think this these things are kind of good at that. These are pretty warm sounding amps, but when you engage the tone controls, they can also be a very forward kind of an amp. They're pretty cool the way they work. I've always liked these Kenwoods from this era, and one of the dealers in our area when I was growing up was a big Kenwood dealer, and actually one of my first receivers that I purchased that wasn't from a flea market or used or something or given to me or whatever was a Kenwood KR-8050, which was a little 28 watt per channel receiver, and I actually did a video on one of those and a little modification on it. But that thing sounded amazing for its age and for how small it was and for how inexpensive it was. And this is kind of a grown-up version, you know. So let's listen to this. First thing we're going to do is we're going to play a little bit of it on the auxiliary input. Then we're going to switch in our inverse RIAA converter, and we're going to feed this into the phono inputs and make sure that the phono sounds the same as the auxiliary inputs. So let's start out. Here we go. Okay, wow, that was kind of like compressing my chest down here. So I'm just using this right here, this little microphone, sitting it in front of the speaker, so I don't know what it's going to sound like. But let's now switch over to the phono input. Okay, the phono is working perfectly. So I am quite happy with that. So I think we're good. I really like this thing. So this is an everything amp. It pretty much has everything you need in it. You could set up quite a system with this thing. It's huge. I mean, it's a lot bigger than, I mean, it's probably got a little, even a bigger footprint than an SX 1050 or something like that. It's not quite as deep, but it is a wide footprint. But man, it's got everything. It sounds good. It works good. It's got a great tuner in it. This will make a great system for somebody, and it'll pretty much drive whatever speakers you have, unless you have something kind of out of the ordinary. But anyway, I'm going to wrap this one up. I'm going to call this one finished and go to the next project on the bench here. Like I said, I'm trying to get through everything here. So until the next video, I wish you all peace, joy, happiness, and good health in your lives. Hope all is well with all of you, and hope to see you all real soon here again on our channel. Take care, everybody. See you next time. Bye-bye.